Hello, and welcome to Astronomy 100. In this video, we're going to continue our discussion of the organization of the sky. And in the last video, we talked about the concept of constellations. We defined what constellations are and gave some meaning to them. But in this video, we're going to talk about some of the details, some of the issues that have to be addressed when it comes to the nature of constellations. So let's go ahead and get started. Now, as we talked about in the previous video, constellations allow us to organize the sky into various sections of the sky. If I refer to an object located in the constellation of Orion, then of course you look for that pattern and you have found the region of the sky that is the one that we're interested in. But there was a problem that had to be dealt with, and if you recall in the last video, it's the International Astronomical Union whose role was to make some sort of an official set of rules that govern various parts of astronomy. And one of the things that had to be addressed is, what about objects that are not located on the actual pattern? So remember, the pattern is composed of a variety of stars, but let's say there's an object in the sky that you want to find that's up here, and it's not part of the stick figure or the figure of Orion. It's nearby, but it's not included in the actual figure itself. So the way that this was remedied was to take advantage of sort of a natural solution that's very similar to the surface of the Earth. So let's look at that again. So this is a photograph of the entire surface of the Earth, and the only thing that's missing is Antarctica down here. But what you'll notice is, again, we have various continents, and on each continent there are divisions into borders that are based on the countries. And so what we can do is take the entire surface of the Earth and we can divide it up into various regions that are based on boundaries. Now you'll notice if I say something is located in the United States, then you can now see that it's somewhere in this region surrounded by these borders. And so if it's not necessarily in a particular major city, let's say I'm looking for something that's not in Washington, D.C., but it's somewhere out in the middle of nowhere in Arizona, I can still say that it is in the United States, and it is of course located somewhere within this bordered region. So we no longer have to worry about the individual places as long as we sweep them all up with a bordered region that encompasses all of those places. Now, here's what I mean. So what the IAU, the International Astronomical Union, did is they divided the entire sky into bordered regions. And each bordered region is a boundary that surrounds a particular constellation. Now, this is an interesting point of view in this illustration here. You can imagine the sky looks like a round thing. When you are on Earth looking up in the sky is all around us. So it almost looks like there's a giant sphere that the sky is attached to, and then the Earth is at the very center of that. So this would be the entire sky surrounding the Earth. Now what I'm going to do is we're going to take all of this and we're going to slice it, and then we're going to lay it flat, kind of like you do when you take the surface of the Earth and you lay it flat into a flat map. So that's what you get here. And what you can see is this is the entire set of 88 constellations. The names are a little bit tough to read, but that's not all that important. But what you can see is that each constellation has a boundary, has a border. There are no stars in this map. The stars are actually there, but this is actually showing you just the boundary. So the patterns make the constellation and give it its name, but it is the border that defines the part of the sky that that constellation belongs to. So the idea is that now every single place in the sky belongs to one of the 88 constellations. There is no place in the sky that you can point to that is not inside of one of these bordered constellation regions. So it is now all inclusive. Now the example I'm going to use is this one right here. This is the constellation called Ursa Major, and here is the border that surrounds that constellation. So let's now kind of zoom into just that one. So you can see here's the boundary. Ursa Major is a Latin word, and Ursa is the Latin word for bear. the kinds that live in the woods, and Major is something big. So Ursa Major means the large bear. Now, many people, when they look up in the sky, they will notice these 7 stars right here. They won't really notice much more. And so you may automatically recognize this pattern as something else, and we'll come back to that in just a minute. But what I want you to notice is, if you lived in a dark region of the Earth, let's say there are no city lights nearby to make it hard to see stars, what you would be able to see are all these stars out here, and they're fainter, but you would be able to see them too. And in our imagination, this would be the body of the bear, and the head of the bear would be up here, the front legs would be here, and the back legs would be here. Think of the bear walking across your point of view. And of course, this bear has a mysteriously long tail to it. Now, just to show you I'm not making this up, here is the original drawing to go with this. So Ursa Major is the large bear, or the great bear. And you might think, well, this is silly. Bears don't have tails long like that. They do have short tails, but not long tails. And again, the reason why this bear has such a long tail is because this would be an opportunity to tell a story. The ancient people of the earth would have a story about the bear to explain why the bear has such a very long tail. So the constellations were pictures that went along with the storytelling, and it would give them a reason to tell a story. So Ursa Major, the bear with the very long tail. Now let's go back to the pattern for a minute. When you look at these 7 stars and you notice that they're brighter stars than the surroundings, what you would find is that these 7 stars stand out, and of course we'll talk about that in just a second. But notice the border. So even if there is an object located right here in the sky, it's not part of the pattern, but a galaxy, let's say, that's up here is still in Ursa Major, because Ursa Major is not defined by the picture anymore, it's defined by the border. So as long as you're inside of this bordered region, you are in Ursa Major. Now, what about those 7 stars? Well, these are what are commonly referred to as the Big Dipper. So I'm going to sort of crush a myth, or do a myth buster here for you. Many people mistakenly think that the Big Dipper is a constellation, but it is not. The Big Dipper is actually a nickname that's given to part of a constellation. The actual constellation is Ursa Major, but these 7 stars are given a nickname because they look like a spoon. Here's the bowl of the spoon and the handle of the spoon. So anytime we give a nickname to a portion of a constellation, we call that an asterism. By definition, an asterism is a nickname that's given to part of a constellation because it looks like something else. So what you would say that is technically correct is the Big Dipper is the asterism within the constellation of Ursa Major. So there are many asterisms in the sky that people have mistakenly called constellations. The Big Dipper is an asterism, not a constellation. The Little Dipper is an asterism. It is not a constellation. And there are many more. So an asterism is just a nickname, and by the way, they are not official. The International Astronomical Union recognizes the constellation of Ursa Major, but anything else we do as a public, these nicknames we give to little parts of constellations, that's just up to us. They're not official, but it's a very common one. So think about that next time you're outside. When you point up at these 7 stars, make sure you don't say, that is the constellation of the Big Dipper. The more correct thing to say is, that is Ursa Major, and those 7 stars are the asterism called the Big Dipper. Now, a couple of things about constellations. The first thing is that constellations are an illusion. They're really not what you think they are. And there's 2 distinct ways that the constellations are a bit of an illusion. The first thing is that when we see the stars in the sky, we are seeing them from the perspective of where we are in the galaxy. And if we go to different places in the galaxy, those same stars will have a different pattern. Now, I'm going to show you how this works. We're going to go to a website, and on this website, there's kind of a neat thing that this person has made available. These are 32 of the nearest neighboring stars to the sun. And the sun is right here at the middle. And what's kind of nice about this is we can manipulate this. This is a three-dimensional representation. So if I simply just grab it with the mouse and I drag it, what you can see is I can change the orientation. Notice the sun is always at the center, but notice if I change the perspective, let's say we go around the galaxy and we go to a very different place, but we look back at the sun from that very different place, you'll notice that the patterns of the stars themselves are all different depending on how we see them. So an example is, if I were to say, hey, these 3 stars in a row are kind of special because they're 3 stars in a row, that's because we see it from this perspective. If we were to go somewhere else in the galaxy, so keep an eye on these 3 stars. If we go somewhere else in the galaxy, notice that those 3 stars are actually not 3 in a row. So it's an illusion that they lined up like that. It was just simply an illusion based on our perspective and where we happen to be in the galaxy. From the surface of the Earth, we don't know that. We can't see the depth. We can't see distance. So it all looks two-dimensional. But when you make it three-dimensional, you can see that the patterns, they're just coincidence. They just happen to be what it seems to be based on where we are looking when we look at the sky. Now, the second way that constellations are a bit of an illusion is that they change over time. When we look at the stars in the sky, the one thing that's not noticeable is that all of these stars are moving. Every one of them are moving. The sun is moving through the galaxy, the stars are moving through the galaxy, and they're all moving fairly fast. For instance, the sun's traveling at about 600,000 miles per hour as it goes around the galaxy. So that sounds extraordinarily fast, but the thing is that the stars are also extraordinarily far away. And so even though they're moving at very fast speeds, it takes many, many years before you would notice that they're actually moving. So what we can do to fix that, to bring the point across, is this astronomer here, what he did was he took all of the stars near the asterism of the Big Dipper, and what he did was he figures out how far away they are. That's something that we know. And he figures out the speed and the direction of how they move. And he allows a computer to essentially speed up time. So you'll notice the time going by up here, and we'll let it cycle through a few times. It starts 100,000 BC. So it starts 100,000 BC. And notice the spoon doesn't look like a spoon. But as the time goes through modern time to 100,000 AD, so a total of 200,000 years goes by, notice the movement of all these stars and how that changes the appearance of the shape. So if we find some sort of significance in any particular shape, the movement of the stars themselves is slowly changing that over a period of time. So calling a constellation special or saying that it has some sort of cosmic significance is really kind of silly because it's actually constantly changing. And it's just an illusion created by how we see the stars and, of course, how we see them over a period of time. Now, why is it we don't notice this? For instance, if you were to go outside and look at the stars tonight, what you would notice is the very same constellation patterns that the Egyptians would have mentioned. So an example is, the Egyptians would have talked about the group of stars that we call Orion. The pattern that they saw is the pattern that we saw. And the ancient Egyptians lived a long time ago. That sounds like a long period of time. But a course of only 5,000 years in human lifetime is huge. For the stars, 5,000 years is not very long. And so the pattern of Orion that the Egyptians saw looks the same to us today because 5,000 years has not been enough time for the stars of Orion to change their positions to look like something different. If somehow you were to be put into like suspended animation today and you were put into a cryo chamber, frozen, let's say, and somebody woke you up in 100,000 years or woke you up in, let's say, 1,000,000 years, you would go outside, and even though you're looking at the exact same stars that you saw when you were first alive, they have all moved to different positions. The constellations would be totally unrecognizable. You would think you're on a surface of a different planet. So constellations are a way to organize organize the sky, and it's also a way for us to be able to make it a useful tool. But remember, when it comes to the patterns themselves, it's just our imagination, and there's nothing significant about them. The subject of astrology really has no scientific meaning, because astrology finds meaning in the patterns when the patterns really are just sort of meaningless. It's just what we see. Now, in the next video, we're going to talk about how we name the stars and how we can organize them in that fashion. We're just about out of time for this one, so I hope you join me in the next one.